Hello everyone, hope you are doing well. In this video, we'll discuss the last problem of Leetcode Weekly Contest 300. It's a hard level problem. The problem name is number of increasing paths in a grid. So we are given an m cross n integer matrix grid where we can move from a cell to any adjacent cell in all the four directions, right? Left, right, up and down. So return the number of strictly increasing paths in the grid such that you can start from any cell and end at any cell. Now since the answer can be very large, return it modulo 10 raised to the power 9 plus 7. Two paths are considered different if they do not have exactly the same sequence of visited cell. Okay. So if we look into the first example, then it's 1 1 3 4. So let's see what are the increasing paths. So if we look into the paths with length 1, then all the elements are actually an increasing path, right? Like all the elements individually will represent a valid case. So 1 1 3 4. So it gives us an answer of 4. Now when we move to the second part, that means paths with length of 2. So 1 3 is one of the valid cases, then 1 4 is one of the valid cases, and 3 4, right? So see, these are the three cases. So initially we got 4 plus 3 in this case, so it comes out to be 7. And then when we look into the path with length equals to 3, so 1 3 4 is the only valid path with length 3. So the total answer comes out to be 8, right? If we look into the second example, so the grid is 1 2. So if we talk about individual elements, so the answer will be 2. That means the count will be 2. And as soon as we move to the to a path of length 2, then 1 and 2 is a valid case. So total we have answer of 3. So actually this is a traditional dynamic programming problem, because you just need to write what the question says. That means traverse the grid, and what you do is basically move in all the four directions. And if you have calculated the result of the condition that you are visiting, then just return it, else you recalculate it, right? So a traditional dynamic programming problem, nothing fancy. I'll show you the code and I'll show you that I've written whatever the question asks me to do, and nothing fancy, and that gives us the answer. So that is why I don't think we need a diagram in this case. Just a second. Yep. So I'll start with the implementation. So let's talk about the main function, right? From line number 28. So here what I have done, just for simplicity, what I have done is that I have added some attributes at class level, grid n and m, so that I don't need to pass it to the DFS function every time. So that's the main motive of this. So on line number 29, 30 and 31, I have done all these things. On line number 32, I have basically allocated memory for the DP array. So this array will be used to store the results that we have already calculated, right? Nothing fancy till here, right? Now as explained, what we will do, we will start from each and every index. What we are doing on line number 33 and 34, we are traversing the grid, and at every cell we are calling the DFS function, and then we are just receiving the function, adding it and taking the mod and returning the answer. This is all about the main function. Now let's come to the DFS function. You'll see again here nothing fancy being done. On line number 13, our function starts. We have passed R and C, that is the current row and current column. Now again, if the value for current row and current column is already calculated, then just return it, don't do anything else. What you do now, as we saw in the question, a single element is a valid case, right? So dp of r comma c will have at least a value of 1, because individual element is representing a valid case, right? Now what we do, from line number 18, what we are doing, we are traversing in all the four directions, right? So we are calculating what is the new row and new count. So new row is r plus r dir of I. So this is a way where we can basically traverse in all the four directions, like one of the ways. There are multiple ways. So you make a couple of arrays, one for row, one for column, and just do it. So you calculate new row and new column, and on line number 21 we check whether it's a valid new row or new column or not. So it just checks whether the new row and new column are within the range or not. And the second question, the second condition in the problem, it says that it should be an increasing path, strictly increasing path. So that is what we have checked, that grid of new column and new row and new column should be greater than grid of r comma c. That means the current row and column, right? So what we just do on line number 22, dp of rc equals to the current value plus the value which will be returned by this new row and new column, right? So dfs of new row and new column, and then finally we take the mod to avoid the overflow, right? That's the only thing. And then finally, since this function was called, we return dp of r comma c, right? If it would have been calculated, if it was already calculated, we would have returned from line number 15 only, but we have calculated it, and from next time we'll return it, right? So yeah, this is the implementation. And why I haven't you explained here, like I've shown you everything in the code, because there is nothing new with the logic. Whatever the problem is saying, you just need to implement it. In fact, to be very honest, I personally feel that probably this problem, that is the hard problem of this contest, is a little bit easier as compared to the third problem of this contest only, right? That was a little bit trickier, I would say. Both are related to dp only, but like that could be solved using dp only. I have already posted a video for that, but this was a relatively traditional problem, right? So I hope you learned something new from this video. Do support it by giving up a thumbs up, do subscribe to the channel, and also if you have any queries, then please post that into the comments. I'll try to answer each one of them, right? So yeah, take care, bye bye, see you in the next video.